First of all, thank you very much to the organization for having me here today. Today's talk is about how you can track threat actors using VirusTotal and through images that are using their initial payloads during their infections. And not only images, but also artifacts that are embedded within their documents. So it's a novel, let's say, approach that we have discovered. We didn't know that it exists, and the users of VirusTotal could do that. And we are here to share this knowledge to the community in order to give you how you can do that, okay? So a brief introduction about myself. I'm Joseliyo, coming from the south of Spain. As I said, I am security engineer at VirusTotal, former McAfee and BlackBerry threat researcher as well. And there you have my social media, just in case you want to contact with me after the talk and share your feedback or comments about the talk. So this is the agenda for today. First of all, I will explain why I decided to do this research, because it's important to know, just to understand the rest of the presentation. The second point is the research explanation for itself, the results that we had. And also, we are going to see some in the wild examples related to APTs and cybercrime groups that we have observed and we were tracking using this, let's say, new technique to do pivoting and also threat hunting. And finally, I will explain some limitations and conclusions about the research. So starting with the presentation, I'm going to explain you a brief introduction about why I'm here. And the reason is because usually I used to do hunting in the intermediate final phases of the kill chain. Usually I used to do hunting on the execution phase, also in the installation, command and control, action and objectives. And many of you, probably you are doing the same. And the reason is because the information that other vendors are sharing about APT attacks or cybercrime attacks in general is most focused on those specific phases. I mean, we have more information about behaviors in those specific phases. And the Threat Micro guys said before in their talk, who wishes to be on the left of the bank? And it's a nice question because sometimes we forget that there are other phases that are important to do hunting and to do pivoting, but we are not doing that at all. Maybe because we don't have enough information, or maybe the data sources are not prepared to share information in those specific phases. So for that reason, I decided to focus my research on the weaponization and delivery phases in this case. And this is what we are going to see. Before we start with the technical details of the presentation, let me explain you something which is important to understand, because it's something that happens to probably many of you, including myself. There is a color theory, an emotion bias. Before we start looking at the details, I wanted to give you an introduction about this bias. Usually, there are a hundred of color psychology studies that have demonstrated that the colors can profoundly influence your decision-making process, okay? And this happens in VirusTotal and other platforms. Usually we see colors like the green color, the red color, representing if something is malicious or not. So for example, in this case, the green communicates peace, growth, and health, and means go. In the opposite, we have the red color, which is most often associated with danger or focused attention. And in this slide, I try to deceive you, putting the wrong word in the wrong color. So if you didn't realize, the malicious word is inside the green color, and the benign word is inside the red color. If you didn't realize, it's because of that. It's because the color bias. And how works the color bias in VirusTotal? This is just an example of a real sample related to Sidewinder APT threat actor, and in the left side we have part of the sample report that we can check in VirusTotal. For example, this Word document was communicating or contains a contacted URL and contacted domains. If you are a CTR analyst and you want to do threat hunting or other activity, probably you are going to start clicking on those URLs or domains that are in red color because it means that it's malicious. And you are going to start maybe your pivoting technique clicking on there. But in the red side, we have also a compressed pattern, which is a zip file. Maybe you are going to click there as well because you want to identify if the original zip file contains other pieces of malware as well. But probably you are not going to click on any of those files that are bundled in this Word document because are green. I would say that the extensions are not sexist at all because are XML, and also there is an image embedded into the Word document. So say that what is there in common in all of these samples that are related to different APTs in this case? We have here documents related to Gamaredon. We have documents related to Sidewinder. I think that APT 28 as well. What is in common in all of these documents are that they were used during the initial phases of the kill chain. In the delivery phase, these documents were sent to the victims, and they were using some images during the creation of the document, just to give more confidence to the victim and try to deceive the victim in order to execute the document and start the whole infection chain in the organization. But as I said, there are images. It's something that is common here in all these documents. And we are going to focus, as I said before, on the images, but also on the artifacts that are embedded within the Word documents or Excel document, Office document in general, that we have observed. So now let me explain the research explanation and what we are going to focus on. First of all, we have the Office document, as I said before. And the Office documents, we are going to focus especially on the images that are embedded within the Word document or Excel. But also, we are going to focus on the styles XML file and the content types XML file, okay? I will explain later the meaning of these files and how are they generated. We are going to focus also in the PDF documents, but in this case, instead of have bundle files, the PDF documents in VirusTotal, it contains drop files, which is different. But there are some artifacts that are also interesting to do pivoting or hunting in the future. And finally, we have other documents. We are going to see an example of email sent to some victims and how from that specific email and also the drop files and the email attachments, we were able to track operation carried out by some threat actor that we couldn't attribute, and how we discovered new emails targeting different companies using the same images. So the Office documents, as I said, there are some threat actors that are using images during their work creation documents, and those images are going to be helpful for us in order to track the operations that they are doing. The content types, this file specifies the content types and relationships within the Word document, okay? This is created automatically by Word. And it essentially defines the types of content and how they are organized within the document. So for example, if you create a Word document with a PNG image within the document, there will be a line in the content type indicating that there is a PNG file embedded and it will be used, okay? The styles file stores stylistic definition for the document. For example, the paragraphs, the spacing, colors, numbering. So I can create my own Word document, and I will create my own styles. And if I do that, the styles, in this case, will be pretty unique because I am creating my own styles. So let's imagine that there are some threat actors that maybe are creating their own Word documents and creating their own styles. So with that specific styles, which at the end contains a hash, is a file that we can take the hash, we can follow the activity of some threat actors. It's also important to mention that there are some content types and styles that are quite generic, so are not good at all to tracking some threat actors, but we got some good results in terms of some APTs that were using the same content types and styles. And these are the facts. We have identified some threat actors using the same image in different moments in time in a different operation during their activities, okay? We have also identified the use of the same content types in multiple documents used by the same threat actor and by different threat actors in their operations at different moments in the time. And the same with the styles file. But as I said before, some styles and content types are quite generic and are not good at all to track and identify new operation because it could be used by legit documents at the end because are quite generic, as I said. So this is just an example of a content type that you can see if you unzip a Word document that you will have in your computer and see the content types, you are going to see something similar to this. And the styles will look like this one. It's defining the different headings and paragraphs that you are going to use in your Word document. So let me explain you now the results. This is the scope that we decided to use in this case. We selected different Word documents and Office documents in general related to these groups especially. We extracted all the information from VirusTotal. And then the first thing that I wanted to know was, okay, per each APT group, I want to know when they have used the same image in different samples uploaded to VirusTotal. So in this case, each of the colors represent an image, which are these ones. These are the hashes of the images. And each bullet that you are seeing here is a sample. So although you are seeing here just one sample, in reality, there is 2 or more samples that are relating or that are embedding the image, okay? But maybe were uploaded to VirusTotal the same day or in the following days. So if we start taking a look on the images, we are going to see, for example, this one. This image is just a line. It's not make no sense. I don't know what it is exactly, but it contains when you go to the image and see the information related to this, you are going to see that it contains more than 100 of files as a parent. In other words, more than 100 of files were embedding this specific image, and APT28 was one of them. So if we move on and we see, for example, this other image is an insignificant image of a hand, and it contains 14 Word documents that were embedding this image as well, okay? And as you can see, the time that the samples were uploaded to VirusTotal are from 2017 to 2022, which is quite fake office for this research. The other image is a fake office-enabled content image, which contains 13 Word documents embedded in this image. This one is, I don't know, exactly. It's like similar to the first one, but it contains also more than 100 files inside. And the last image is a fake EDA roadmap of the European Commission, and it was contained by other 4 files, other 4 Word documents inside. There is something interesting in this image, and it's that in this case, the format was EMF, which is an old format used by Office when they were, I think it was created by Office, and it's an extension that they are not supporting right now to embed the images or something like that. I don't recall exactly. Okay, so let's take a look to the insignificant hand that we saw previously. If we take that image and we go to VirusTotal, as I said before, there are 14 different Word documents that were embedded in this specific image. And if we take a look of the documents, all those documents were related to the same campaign, which was reported by Mandian, threat analyst related to APT28, targeting hospitality sector, okay? But if we see the documents that they were using in this case, as you can see, this is the original document used by APT28, and there is a hand close to the signature and the passport number fields that is the image that they were using. And just in case that we were aware of this image before, we couldn't track the different samples that were uploaded after the initial report that was created by Mandian, which was in 2017, okay? This is just an example of how we can use the images in VirusTotal. The other thing that I wanted to explore was, okay, how, in this case, Gamaredon is using the different, or is having the same content times in the time during their operation. And this is the image, the graph that I got. All those hashes are related to the content types that were used by Gamaredon at some point in the time. As you can see, there are some content types that were used during different points in the time, but some of them were used in the same time, in the same day or on the following days. And the other thing that I wanted to explore as well was the styles. Okay, so for example, having Gamaredon as an example, I want to know when they are using the same style file in their operations. The main difference here between the styles and the content times is that here we can see that the styles are more related to be using the same samples that they are going to distribute in the same days in a short period of time. So as you can see, usually we are seeing just one bullet, but it means that there were 2 or more samples related to that content time distributed in the Word document. And the other thing that I wanted to explore was, okay, taking as an example Gamaredon, I would like to, or with the entire scope of the styles that I have through VirusTotal, what I did was, okay, I'm going to identify some patterns in the styles. I'm going to create a Jara rule, and then I'm going to run the Jara rule to identify new styles that were uploaded to VirusTotal and that maybe are not related to Gamaredon, but could be related to other groups, and will be interesting to see new styles that could be related to malicious activity in general. So I did that. I got this result. There are I discovered new styles that contain some patterns used by the original styles that were attributed to Gamaredon, and then I decided to focus on one of them. So in this case, I decided to focus on this style, but if we see, this graph represents the relationship between the styles and the parents files. I mean, all the different entities that you are seeing in red color are the Word documents that are related to the specific styles. So for example, if we see this style, it contains as a parent a bunch of Word documents that were detected by multiple engines in VirusTotal. So as I said, I wanted to focus on one of those styles in order to get more details and see how it works, okay? So taking as an example this style, it contains in the relation tabs in VirusTotal 17 compressed parents, which means that it was used or it was embedded within 17 Word documents. So taking a look at the documents that were used in this case, the documents were like this. Almost all of them were like this, okay? It's a fake document created to deceive the victims and is impersonating the embassy of Ukraine in Hungary, okay? And now we are going to see how, from the styles file, we can pivot to the other approach that I was talking before related to the images, because as you can see in this specific document, there are multiple images that were embedded within the Word document. And it is really interesting because we can now pivot through these images to identify new files. So I decided to do the pivoting, in this case, with the Facebook logo. And then what I saw was that this Facebook logo was used by multiple samples related to Gamaredon in the time. And as you can see, there is a pattern where we can see multiple images that were used in different or in the same Word documents related to Gamaredon. And all these images are these ones, are all these images. Okay, so this pattern represents this campaign, which was related to Gamaredon, using the different images related to Facebook, Twitter, and other logos. Cool. The other question that I wanted to, that I asked to myself was, okay, are there some styles files that were shared by different threat actors at some moment in the time? And the question was answered as yes, yeah. There were some threat actors that were using exactly the same styles file within their Word document. Obviously, I can say that they were sharing documents or they were sharing information between them because, as I said before, there are styles that are quite common. So, but it is something that is interesting to take a look and go with and analyze with more details. Maybe not with APTs, but with some cybercrime groups that you are tracking and you are trying to attribute. It can help you to identify new documents that were uploaded to VirusTotal related to some specific threat actor. And I had the same question for the content types. And yeah, there are more content types than styles shared by the threat actors during the time, and it's the same. Quite interesting to go and explore with more details and see if there is any reason because some style or content types were quite common and used by some threat actors. And the other thing that I wanted to explore was, okay, now that I have all the images related to the Word documents used by the APTs, the other thing that I wanted to do was I wanted to identify if the AI, in this case Gemini, could help me to identify proactively the images that were used by the Word documents just to see if I could create any kind of a script or something to automate the detection of malicious documents used by APTs or cybercrime groups and get notified when there is a government logo or something similar into my email. And I have to say that the results in some cases were quite nice. In this case, you are seeing different images that were used by APTs, and the response in all of them was nice. As I said, these responses were nice because it contains a logo of a specific government or it contains a specific person, and in this case, the AI could help me. But when the image is not related to any logo or to any person, the results are not good at all. So for example, here we have an image of a random image, and in this case, Gemini told me this is a Citi, Deutsche Bank, and MasterCard Visa logo. Okay, maybe I'm not seeing something that Gemini is seeing, but well, and the same for the rest of the images. The responses were not good at all, but yeah, it's something that we are still exploring, and maybe using ChatGPT or other LLMs can be nice to implement in this case. Well, now let me explain you how it works with the PDFs. We are going to take as an example a PDF used by Blind Eagle, which is a cybercrime group originally from Latin America, targeting mostly Ecuador and Colombia. This specific sample related to Blind Eagle contains, or when it is executed in our sandboxes, you can see that it is created or opened by Acrobat Reader. And there is something that we didn't know, and it is that if you have installed Acrobat Reader and you open the PDF, it automatically creates a thumbnail of the first page related to the PDF, and it stores the image in this specific path, in the connector icons, which is pretty cool, and we didn't know that. So knowing that, all the PDFs that are executed in VirusTotal contains a drop file related to the first page of the PDF as a drop file, okay? So the drop file is a BMP format, and if we take a look in this case of Blind Eagle and see the relations of that specific image, we got other PDF files related to Blind Eagle as well that contains the same image. Well, this is good, but it's not the best approach, because if you change anything from the PDF, any letter, or you just change the size of the government logo of Colombia or whatever, the file hash of the image is going to be completely different, and you are not going to be able to track new activity. But for some cases that we have observed in VirusTotal, this approach was really nice to follow and to identify new samples. And the last part that we wanted to track as well was the emails. So in November of the last year, sorry for the Spanish because it was a campaign targeting Latin countries. There was a campaign targeting, as I said, Argentina, Colombia, Ecuador, Chile, where the threat actors were distributing agent Teslas, snake keylogger, another kind of malware. And in this campaign, they were impersonating universities from Latin in this case. Okay? So as you can see here, we have the University of Chile logo, the building of the University of Chile, but most important for me in this campaign was the logos related to the social media and the footer of the email. Why? Because if this specific threat actor wants to replicate the campaign to other university, they are going to use a different logo related to the university that they want to impersonate. But maybe they are going to use the same footer for the next email. And that was what I was trying to identify. So I decided to do pivoting with the images related to the email. As you can see, the images are in the mail attachments. And if you click on one of them, you are going to see that there were other 33 emails related or embedding some image that was used previously in the footer. And what we discovered in this case is that it was a campaign not only for LATAM, but it was a worldwide campaign targeting different universities in the world. So in this case, we have an email related to the University of Bucharest, University of Taiwan, and University of Colombia. Okay, just clicking in an image which was embedded within the footer in the original email that I discovered. Okay, so just finishing the presentation, these are the conclusion and limitations. We can potentially trace malicious individual by examining evidence linked to the initial document they are using during their campaigns. Something important to mention is that nowadays, we do not incorporate the bundle files into the JSON structure that can be used to create lifetime rules. I mean, you cannot create lifetime rules based on bundle files of Word document nowadays. It's something that we are exploring to add, but instead of that, you can use the files drop. And this can be used, for example, for the PDF files. If you remember, in the PDF file, the image is as a drop file and not as a bundle file. In certain situations, styles and content types files within Office documents can provide valuable clues for identifying and tracking threat actors. Okay, some of them are are not good at all to track, but some of them, at least, we got good results with some APTs. And the method presented can offer an alternative to traditional threat hunting. And this is an addition. I mean, we are not trying to replace any traditional threat hunting activities. This is just a new way to do hunting and pivoting, okay? We are going also to create a blog post explaining everything. So next week or this week, I'm not sure, we are going to divide the blog post in two series. The first one for the Word documents, Office document in general, and the second one will be related to emails and PDF files, okay? So if you have any suggestion, you can contact us through our Contact Us website. And if not, you have my social media and also my email here, just in case you want to ask anything related to the presentation. So that's all from my side. Thank you very much.